My name is Chelsea Troy. I'll talk a tiny bit more about myself a little bit later, but you're in the workshop Tackling Technical Debt, an Analytical Approach. If you're looking for joint cognitive systems, that's across the hall. I will not be talking about that, but yeah, I guess let's go ahead and get started. Here. So, the first thing to know about this workshop is that we're going to cover a lot. I see a 99-minute timer in front of me. The schedule said 2 hours. I will take the entire 2 hours. However, it is going to be relatively fast-paced. Hopefully, you're going to learn a lot. And if I do not get to a question that you have, which may happen, please feel free to post it in the Discord channel. I'm going to be checking that after the workshop and throughout the weekend. And the benefit of posting in that channel is that other people will get to see your answer as well. So if we run out of time for questions at some point and you still had a question, do not worry. We will definitely get to those. Feel free to post them in the middle of the workshop, and I will just check them afterwards. So that link is in the slide, which you should all have in the Discord channel. Finally, there's currently plans to turn this into a little bit of a longer version of a workshop for Graceful Dev, which is a project that Avdi Grimm is doing. So I will be interested to hear your feedback on this workshop to find out what to expand on. Finally, if you are a tweeter, there are 3 handles there. Please feel free to include them in your tweet. One of them is, of course, the RubyCond handle. One of them is my handle. And then one of them is the handle of my lovely assistant, Leah Miller. I guess that's about it for this slide. So, whoa. All right, so like I said, my lovely assistant Leah, throughout this workshop, we're gonna be asking y'all for some input at various points. Very, very important that it goes into the mic. However, for accessibility reasons, what we're gonna do is we're gonna have Leah bring the mic to you. So if I ask you to raise your hand, Leah gets to pick who is going to get it if we only have 1 or 2 people. So, so that is the plan, so that everybody gets on there. If I have you raising your hand and folks are going to come around, please just wait until you have the mic, and that way we can hear your beautiful voice explain your question or your story or what have you. Finally, this is me. This picture was taken in my home city of Chicago. You can almost see the Sears Tower there behind my head. We don't call it the Willis Tower. So if you ever come and you hear that, don't subscribe to that. Okay, so let's get started. What is technical debt? Now, I think there are a couple of misconceptions about what technical debt is, so I want to go over those real quick. We all have an idea of what it looks like. I suspect we all have an idea of what it feels like. Hands up if you know what tech debt feels like. Okay, that's a lot of the room. So, a couple misconceptions about it. The first misconception that I want to dispel is that tech debt is tantamount to bad code. There are a couple of reasons that this misconception is harmful for us when we're trying to talk about the state of our code base. The first one is that it causes us to equate the developers that came before us with bad development. That's usually not the case. There are a lot fewer really terrible engineers than there are good engineers who had to do something under constraints that we do not understand, that caused the code to be the way that it is now. So that's the first thing I want to mention. The practical reason that equating tech debt with bad code is an issue is that it puts us under the impression that if we write good code, then we are not adding maintenance load to our code base, which is not true. We're going to talk about maintenance load a little bit later. Second misconception about tech debt is that once you build a feature, it is free. Once you have built it, once we are done, once it is shipped, once it is working, we don't have to worry about that feature anymore. We don't have to take it into account when we are writing further code. That's not the case. On features, we pay rent. We have to do maintenance on those features. And that's where this term comes in that I mentioned earlier, maintenance load. I like to define technical debt in terms of 2 other things, which we're going to go over. The first of them is maintenance load. Maintenance load is the proportion of total developer effort spent on maintaining the existing feature set. So if you have one developer and that developer spends 4 1 day, let's say, working on features, and 4 days on other tickets related to maintaining the code base, then the maintenance load is 80%. So a couple examples of what kind of tickets would count as maintenance load might be updating or upversioning or investigating existing code. Hands up if you've done something like this. Congratulations, you have done maintenance load. Determining whether a given feature ever worked. People done this? You've done maintenance load. Did you figure it out? Sometimes I haven't. Adjusting deployment so that existing functionality will scale to new scales. Have folks done this? Few hands, yeah. You've done maintenance load. The heuristic I use to determine what's maintenance load and what's not is this. Any developer activity that is not adding a feature or removing a feature counts as maintenance load. Now, we can get into depth on what a feature is. We're not going to do that for now. But take your definition of a feature. If you're not adding one of those or you're not removing one of those, whatever else you're doing, maintenance load for the purposes of this workshop. The other concept that you need to know when defining technical debt the way I do is context loss. So, context loss is a lot of the reason that we end up doing this work. Very frequently, when I've gotten into code bases where I was told that there was a lot of technical debt, particularly earlier in my career, I would equate that with bad code and think it's very convoluted or something like that. Sometimes I was even told that that's the way it was. And then I would get in that code base and I would realize this code isn't that bad. It's just nobody here knows how it works. That's context loss. It's missing information about how, whether, or why a piece of the code base existed or worked. It has very little to do with the quality or functionality of the code itself. It has everything to do with the way the context was shared or stored or broadcast, or not shared, stored, or broadcast among the remaining team members. You can get context loss for a number of things. For example, something wasn't documented and the team forgot. That's context loss. Only one person ever knew and that person left the company. Hands up if this has happened to you. Huge source of context loss right there. This is why churn events are so risky technically, is they drive your maintenance load way up usually. Another way might be that the code is so complicated that even the original author isn't sure what's going on anymore. Hands up if this happened to you. My hand is up. Yeah, this happens. I teach computer science students. This can happen as fast as 4 weeks or 6 weeks if it's something sufficiently complex. So that's context loss. So now we've got maintenance load, we've got context loss. We're ready to talk about what technical debt is. Tech debt is maintenance load in the existing code base that comes from context loss. So that's what it is. That's what it means. So how do we quantify that? Well, we can quantify that in terms of how much of our developer time and effort is getting spent. What? Fantastic. How do you know if your maintenance load is under control right now? So we talked about a number, but you're all in this room, and you didn't know that definition or that numeric quantification before we got in this room, so you must know somehow. What are some of the signs? Signs that your maintenance load is not under control might include agreements with products to take on tech debt to deliver a feature. Hey, this boat's got to get from here to there. Do you mind taking on a little water just until we get there? Promise we'll let you bail it out when we get there. Maintenance load's not under control. Another example, the team has accepted that there's some features that just don't work. Show of hands, y'all have this going on? Couple, yeah. Support teams that have just been told, yep, tell them the manual way. Just do it manually for them, the button doesn't work. Maintenance load's not under control because we're not able to maintain the corpus of features that we're committed to maintaining according to our user interface. Another example, there are repositories or features that the whole team avoids. Anybody had this experience? A repo nobody wants to go into, a legacy API nobody wants to touch. That's right, okay. Anything where the entire team at stand-up is like nose goes, that's an abandoned house. These are signs that your maintenance load is not, in fact, under control. So now I've got an individual question for you. I'm going to have everybody answer this individually. But that link right there, where it says here, that links to a Google Doc, and I want folks to feel free to type it in there, because I think it'll be interesting if everyone can see everyone's responses to these questions. First, what is your worst maintenance load horror story? What is your worst maintenance load horror story? And then, how about the opposite? Situation where things were smooth, easy to maintain. I'll give you a couple minutes to type something into that doc. Would anyone feel comfortable to share their answers to this question? You can put your hand up if so. Leah will bring the mic to you. We've got a couple over on the rail here by the doors.
So we have a legacy server that nobody knows how to maintain with legacy code that no one codes it anymore, that we somehow have to keep running.
Sounds like fun.
If you spell fun with a PH.
Oh my gosh. Amazing. Anyone else? All right, we got one over here.
Years ago, I worked in a support department for internet banking. We did a professional services contract for a client, took them live on a new copy of their internet banking site. 4 months in, they reported a few users weren't receiving some alerts, and I discovered that that alert had never fired in the 4 months that they'd been live.
Awesome.
It never worked.
Lovely. All right, maybe we can do one more. Do I see anybody? Show of hands. Oh, it looks like you've got somebody.
A team was underwater with on-call responsibilities, so they added a second person to on-call.
Amazing. Good maintenance load horror stories there. I have a couple myself. I work on one application. Well, that's not a fair characterization. I work on a couple different applications where, as we discussed, a developer built the application and then left for various reasons, and it's the company or the organization has been sort of using it for a while. A lot of interesting stuff happens in those, but they're fun to learn to spelunk. Okay, so now I've got another individual question for you. This one I'm going to give you 5 minutes for. What practices distinguish your maintenance load horror stories from good stories? Now, here's what I mean by that. What is your team doing in the maintenance load horror stories? What is development like on the code base with the maintenance load horror stories versus what is development like on the code base where you have the opposite of that, where you have a smooth experience, where the app feels maintainable? What are the differences? And I'll say some of these differences might not necessarily be programming practices. It could be age of the code base. One of them's 10 years old, one of them's 6 months old. That's a big difference. Or the differences might be size of the team. But there are also generally practices, the way that the team approaches documentation, the way that the team approaches testing, the way that the team approaches meetings. So what I'd like you to do is write down somewhere on your own computer. We're going to use these later. Think about your horror story and the opposite, and ask yourself what practices distinguish those two teams. And make a little list. We will use this list later, so actually do the exercise. So you've got your list. We'll call that our cliffhanger for part 1 of the workshop. We're going to come back to those. So keep them in mind. So now we know what maintenance load is. Let's talk about why maintenance load rises. So there's another critical concept here. I call this code stewardship. Not positive I like the term code stewardship, so if you have a better idea for what to call this after we talk about it, feel free to tweet it to me because I am taking submissions. But for now, we're going to call it code stewardship. And it is specifically the skill of reducing maintenance load. Now, I want to be clear. We cannot eliminate maintenance load unless we eliminate all of the code because we have to maintain the system. But this is the skill set of reducing maintenance load. And it's a skill set that we don't tend to incentivize or prioritize in programming, education, and professional programming environments. The places that do are anomalies. But it includes something, I'll give you 5 examples here. It includes writing discoverable code. By this I mean writing code that somebody who has not seen this code before will be able to go in and use the code itself as an artifact to understand what the system is supposed to do. That's discoverable code. Another example might be writing code with the malleability and rigidity in the right places. And I want to explain what I mean by this one, because we often say that we want to keep our code flexible, right? We want to keep our code flexible. What are some other things we want to do with our code? Folks familiar with dry? Don't repeat yourself. Okay, so we want dry code, but we also want flexible code, right? Suppose we dry up some code from 2 different places, and then we find out that one of the places needs to change. Is it easy to change relative to the way it used to be? No. When we dry up code, we trade malleability for the conciseness of that code. We make it more rigid because we are trying to get some other things. We are making a bet. We are making a bet that if we want to change this thing, that means we want to change it everywhere. And if that bet turns out to be wrong, then our code is not malleable in the ways that it needs to be. Now, I want to offer some grace here. It is very, very hard to make code malleable everywhere. I'm not sure it's possible to make code malleable everywhere. Or if you were to do it, you would have to give up all kinds of other things. You would have to give up dryness, for example, because every single instance of a place where you do something needs its own copy of the code for it to be independently changeable. And that also means that if you do want to change something everywhere, now it is difficult. That malleability isn't in the right place either. It is very hard to make the code malleable everywhere. I'd say impossible. So what we have to do is figure out what is the most likely to change about our code in the future. And we have to make bets by placing the malleability of the code in those places where it is most likely to change. And probably the trade-off will be making the code more rigid in places where it is less likely to change. But those rigid areas are supporting the malleable portions of the code base. We're putting our malleability and our rigidity in the right places, because when we try to make code flexible everywhere, it usually ends up being flexible nowhere. Another example of code stewardship might be documenting code with detail in the right places. Show of hands, who's read documentation that did not help you figure out how to use the library you were trying? Yeah, it's most of it. And it's not entirely programming teams' fault. Code stewardship, like I said, is a set of skills that we tend to undervalue, under-incentivize, under-teach, and that comes with documentation too, and we ask programmers to be good writers and good indexers and good teachers and that kind of thing. That's a separate skill set, and it's a difficult skill set. It's a difficult skill set. Writing is hard. And so when we ask programmers to do that on the side of their programming job, yeah, a lot of the documentation ends up not being what we want it to be, right? But that's a code stewardship skill. Here's another example, writing tests that convey code functionality and boundaries. So tests are really valuable for a number of things. Automated tests can help us catch regressions in our code base if we accidentally break something. They can give us the confidence to make changes, even big sweeping changes, without worrying that we've introduced regressions. Tests also can serve as living documentation for our code. If code is going to change often, it is helpful to have documentation that either changes or deletes itself, or tells us that it becomes invalid at the point where the code changes, right? And tests are exactly that. When I get into a new code base that's well tested, I like to use those tests as a laboratory to understand what the code does. I can change things in the test and figure out what's gonna break, how it's gonna break. I can understand exactly what people expected my code to do. A lot of times I can also tell how this code has broken before, because there's an automated test in there that's like, test, it doesn't do that thing, and that's the name. That's valuable information too. Here's another example, transferring context to other members of the team. This is a really valuable code stewardship skill, and it's the one that we haven't exercised entirely if somebody leaves with a whole bunch of context, right? And I wanna say that on this one, the smaller the team working on an individual unit is, the more deliberate we have to be about this one. I'd like you to picture context for now as a giant beach ball, this big, okay? And if I throw it towards you right now, do you think it's likely to hit the floor? I don't think it's that likely to hit the floor. And the reason is that there are a lot of you and you're pretty close together. So it's probably not gonna hit the floor. Now, suppose that I was in here and there were like 5 of you interspersed around the tables, not working closely together, not so many of you, and I throw that beach ball, there's not likely to be somebody who just happens to be where it is when it hits the floor. And so if somebody is not going to be available, they have to deliberately hand that beach ball off to somebody else. That's context transfer. We could do it through pull request reviews. We can do it through documentation. We can do it through testing. We can do it through artifacts. We can do it through a lot of these other means. So now I'm going to give you an individual exercise, and this is where we come back to the list that I had you write earlier. Earlier, you considered what practices distinguished high and low maintenance load accumulations on teams over time. Horror story code base and the smooth and easy code base. Now, what I'd like you to do is take those examples and copy them one by one and paste them into this easy retro that's linked in the slide. Under what kind of example it falls in. So what I want to know is those practices that you listed out, do they fall under any of the 5 examples that we just talked about of code stewardship? And if so, then you can copy them and paste them into that column on the easy retro. Now, if you've got a practice that does not fall under any of those 5 examples, what I would like you to do is put it in the 6th column for other examples of code stewardship. So I'll give you a couple of minutes for that. If anyone has trouble accessing the easy retro, just raise your hand and we'll come and help. We're experimenting with methods here. This is my first time doing a workshop of this size in person, so. So I'll give you a couple minutes to copy and paste your stuff in there. Let me see if I can pull it up so you can see on the big screen this easy retro. Oh, we got some stuff. We got some stuff. Now I need that horse race music. Cool. Keep typing. I'm going to start reading off some of these examples. So writing discoverable code. Somebody says it was a newer repo that was fairly small and narrow in scope. The changes all followed the paradigms that were set up from the beginning, including the testing suite, making changes easy and safe. I like this one. I want to point it out specifically because for those newer code bases, you generally have a small enough number of features that a team can stay on top of it a little easier than if you're talking about a code base that's 10 years old, right? Gives you a lot more control over what's happening in the code base. Favoring readability over terseness and cleverness in writing discoverable code. High cohesion, solid object-oriented design patterns, a well-defined set of design patterns. Often Your team agreeing on what practices you use is more important than whatever practices you used. As long as you can pick something and agree on it, what the thing is less relevant. So malleability and rigidity in the right places. Avoiding premature abstraction, I like that one. I give another talk about refactoring, and I like to talk about the rule of 3 in that one. I don't generally consider consolidating until I have 3 instances of something, because I do not trust myself to predict with less empirical evidence than that what's actually the same. I've messed it up too many times. Let's look at some more. Heavy use of interfaces and private methods. Open discussion with product about possible ways product will change. This is super helpful. We're going to talk more about talking with product a little bit later. Tests that convey code functionality and boundaries. Good test coverage. Testing suites are ignored because writing the tests are too difficult and time consuming. That must have been one of those nightmare code bases. Fast CI and frequent deployments. Yep, having a small, tight feedback loop can be super useful from a pragmatic perspective, because if it is logistically difficult or even impossible to run your code base frequently and easily, people won't do it. And it's not because they're trying to be naughty, it's because they can't get their work done if they try to do that. Okay, documenting with detail in the right places. Clear documentation written without assumptions about what the reader knows or can do. Good documentation that included examples where similar changes were made. I like that. It's very helpful to have sometimes a PR to follow that you're doing something like. I work on a programming language called Rock. It's a functional programming language. Compilers written in Rust. We're adding a lot of built-ins to it, which are things like find the max in this list, find the minimum in this list, find the last item in the list, the first item in the list, the item at a given index. And often, when somebody's adding one of these built-ins, we can point them to a similar built-in that gives them the opportunity to see, this is where we made a very similar change. You're going to largely follow this. Consistently created architecture design records. Documentation that focuses on the shape of data at key points in the flow. All features tied to a story or ticket. Extensive documentation on both technical tasks and decisions made. Adding a README in the subfolders is specific to the content inside of the folder. That can be very helpful. Very often, the first instinct when we're supposed to document more is to add more stuff to the README, and eventually you have like a 6,000 word README. And it's absolutely beautiful from like an artistic perspective, but it's hard for devs to figure out what they're looking for. So that can be helpful. Transferring context to other members of the team. Structured knowledge sharing, mentoring, pairing. Pairing is one of my favorite ways to transfer context. Doesn't work always, but in the right situations, it can be very helpful. A bus factor greater than 1. Fewer people to coordinate with, that is definitely a reason that context transfer would be easier. Clear ownership of modules or applications. That can be helpful too. So on a number of open source projects with very small teams supporting in the end thousands or even tens of thousands of client developers, it's not necessarily plausible for them to pair all the time. Sometimes one of them lives in Australia and one of them lives on the East Coast of the United States, and the time zones just straight up don't overlap. And so what they'll end up doing is saying, you're responsible for this piece and you're responsible for that piece, and on absolutely need-to-know basis, you'll ask each other questions about it. And it ends up working. It's not pairing, it's not continuous context sharing, but it is very deliberate about the way it approaches context sharing. And it'll work for those teams sometimes. Okay, so this is my favorite part. A different example. Let's take a look at some of these. Solid processes of canary and limited traffic releases. Canary being like pings that test your API regularly. Is that what we're talking about? Breadth is always better than depth. Pushing back on product when we believe that a simpler version of a feature will meet the business need, rather than accepting all requirements as immutable regardless of the complexity incurred. I love this one. We're going to talk about this one later. Kudos, this person. Having a maintenance week and other allocated time just for engineer-driven initiatives, dedicated time or week to tackle and shorten maintenance load, not measuring or caring about what proportion of time and effort we spend on maintenance and bug fixing. This sounds like one of those horror story ones, and it's a tough one because most teams don't measure this until the ultimate metric, which is developers quitting. And that's bad, right? Because developers quitting, like we said, is a churn event, which does what to maintenance load? Drives it even higher. Adding refactoring efforts to the time estimates for a new feature when it's related to that feature, even if you don't have to refactor now. This one is really helpful. It's one of the micro ways that developers can use some of their limited individual power in institutions is to say, that refactor is part of this feature, we're just gonna do it together, and it's gonna take the time it's gonna take, to the degree that you can. Doing continuous maintenance on dependencies instead of waiting a long time before doing this. Yeah, a bulk update or a big update of dependencies can be a big pain in the neck. Discussing incidents in the context of, can we prevent this? I also like this one a lot. I've been in a number of incident reviews where we talked about the response and didn't get the opportunity to quite get to, is there something we can do to make sure that this doesn't happen again? But that can be really valuable too, both from a stress reduction perspective and from like a pragmatic perspective. So we've got some examples, right? Excellent. So this is what we're gonna do now. Am I on time? I am on time. We're gonna take a 10-minute break if you need to grab tea or pee or those kinds of things. Then we're gonna go over some more stuff when you come back. At the end, we're gonna have a larger, more comprehensive exercise. Also, if you've been looking to leave but you didn't want me to notice, now is your opportunity. People came back. What's that quote? If you love something, let it go. Fly is back. Ooh, this is great. All right, we did our 10-minute break. Everybody ready to continue? Fully fueled and ready to rock? We're gonna talk some more. So we talked about what maintenance load is. We talked about what drives it up. We talked about how you might try to keep it down. But what if you're in the situation where you're bailing the boat and you need that maintenance load to come down quickly? That's what I suspect most people are trying to get out of this talk, an analytical approach to technical debt. Another title that I use for this sometimes is technical debt first steps. And a lot of the professionals who show up to that, that's an online thing, I do that with O'Reilly, and a lot of the folks who come to that, their maintenance load is already so high and they need to bring it down quickly. So we're gonna talk about how you might go about bringing down maintenance load now. We talked about why it rises, we talked about how to prevent it rising, now we'll talk about how to bring it down. So there are a couple steps. Step one is gonna be to identify culprits in the code. And in this section, I suspect I'm gonna say some things that are not what you think I'm gonna say. So we'll see what you think. And then the second thing you wanna do is prioritize high leverage changes. And by high leverage changes, I mean changes that are going to bring down your maintenance load quickly. Let's go through this step by step. Step one, identify culprits in the code. So teams will often do this. They'll try to set aside time to specifically pay down technical debt. Can I see a show of hands who's been on a team that's done this? My hand is up too, yep. So this is, from a theoretical standpoint, this approach makes a lot of sense. And sometimes we come out of it with changes that are helpful. I find that the signal to noise ratio on the changes that get made in a week like this tend to be lower than I would like. And I think the reason is that taking time with a clean bill of paying back technical debt is too vague. It ends up leading to renovations that don't really reduce maintenance load. So that brings us to an uncomfortable, potentially, conversation, which is the conversation about code renovations. And the reason that this is an uncomfortable conversation is that many of us, myself included, have done this thinking that we were materially improving the code base. What is a code renovation? It is a change that developers make to working, maintainable code because that code does not match their personal architectural preferences. The reason that I call it code renovations is because if we imagine maintaining code like maintaining a building, I don't like to use those kinds of metaphors to describe software engineering that much because they often break down pretty quick, but in this case, it's opposite. You can fix windows, you can fix the roof, you can fix the plumbing, you can change the grading under the house so that the basement floods less often. Those are all maintenance. And you can also trade out the kitchen for a really gorgeous marble, pink, gold. Let's just say that this is all good design decisions compared to what it was because you didn't like it, right? And it's prettier, you like it better, but does anything on the house work better than it did before? Probably not. If you have good contractors, then nothing doesn't work that used to work, but that sometimes happens too, right? Now, pet refactors often fall under this code renovation category. And they're fun, they're often fun, and the developer who's doing them often learns something, and maybe if the whole team agrees, then everybody even likes the code better, but often they're not done with full team agreement. They're done because some individual was interested in driving through this change, and the team didn't necessarily agree, and so it took some time during the refactoring week to just shove it in there. Everybody will like it once it's done. These kinds of changes don't reduce maintenance load, and in fact, they often erase context that the team already shares about how the code works. What happens to maintenance load when context is lost? Yeah, it goes up. So a lot of times these pet refactors end up increasing the maintenance load because it means the rest of the team now no longer understands a pattern in this code base, and they need to take time and effort to learn this pattern. Is that adding a feature? No, it is not. Is it removing a feature? It's not that either. It's maintenance load. It's something that devs are having to do to maintain this code base. Now, here's a question. Have you performed something that you now suspect of being a code renovation? Show of hands. My hand is up. Yep. It's common. I worked on a code base where we had this absolutely brilliant iOS developer, amazing, understood all of the internals of iOS, was working on a team of 8 people. The other 7 people were not as deeply familiar with the internals of iOS. This developer did not like the way that you navigate from screen to screen in a standard iOS application, so they built their own completely functional screen navigation library, and they made our application depend on it from their personal GitHub. This was a health insurance application with about 11 million end users. Yeah, and it worked great until the day it didn't. And on the day it didn't, he had been rotated to another project because I was working at a consultancy and people rotated every 3 to 6 months. He wasn't there anymore to explain what was going wrong. And the problem with navigation was not Googleable because the way that everybody else does navigation in iOS was not this. So it was impossible for developers to find artifacts that would help them fix the issue in this developer's absence. And I ended up spending a week putting that code back in plain old, like, not iOS whiz genius terms that were Googleable and were the way that most people were doing screen navigation in iOS at the time. One time earlier in my career, I changed a whole bunch of stuff from static methods to instance methods, and then I instantiated instances of those classes in order to call those methods, because I had learned that static methods were bad and lots of little objects were good. And I don't think that changed the amount of time that anybody took to maintain any piece of that code one bit. It did not improve the developer experience at all. I think I got lucky. That particular thing didn't make anybody confused about the code because it was essentially adding an invocation between the name of this class and the method. But it did not help. It was not helpful. And I spent several days doing this because I was convinced I knew how it went. Anybody want to share their code renovation stories? Show of hands, maybe? Do you have a brave soul? We'll appreciate your sacrifice for the good of the group.
So before we had RubyCond, we had many conversations on code style. And I spent multiple days switching all of our double quotes to single quotes when I could.
That's a good one. Let's give them a hand, folks, for their bravery. This is sharing your mistakes with a room full of like 150 people is not an easy thing. That said, anybody else want to do it? Oh, sweet.
So that prompted a memory of the same thing in JavaScript, where we got into a discussion of whether we should put semicolons at the end of lines or not in an existing project with lots of code.
Excellent.
Someone submitted a code change. Before the team had agreed fully as what to do, someone submitted a change that was functionally 4 lines of code and 230 changes in the file,
Oh my gosh.
and created a rather large incident in a meeting for the team over that
Oh no.
and what to do next.
Oh man. That's good. All right, let's give them a hand. Anybody been on a team where you had some version of the semicolon wars? Where like some people remove the semicolons and other people come through the file and they add back the semicolons, and it's like this passive aggressive king of the hill game, and whoever maintained it last, you can tell where they fall on the semicolon wars lines. That happens. That one's not too harmful because the code looks the same, but sometimes you get a big refactor and it's like, we wanted this to be functional. Why? Because we like functional code. That is great. But our production application wasn't the place to change all that unless we had a material benefit from it. So that's a code renovation. Congratulations. We got through the code renovation portion of this workshop, which is the most awkward portion. So it's all downhill from here. So here's what I'll say, is that, so how are you going to identify these culprits in the code if it's not just based on what you personally don't like? This is a place where I recommend collecting some data from your team, right? You have some options here. You could potentially, show of hands if your team uses retros. They use retro, yeah, okay. So what is a retro beyond a sanctioned place where you are allowed to complain about things in the code base? This is a great opportunity to do it. And conveniently, you already have notes on your retros, potentially pictures of them. Maybe you keep them in a Google Doc somewhere. So it's a great opportunity to go back and look at what developers are repeatedly complaining about in the code base. That is often a great spot to start socializing some changes that would reduce maintenance load. Another option would be take a look at your incident reports. Look at your incident reports. What's causing incidents? Very often, the reason an incident happened was somebody made or pushed a change where they thought they knew what it did and they didn't. That's context loss. That's an absence of context. So that's a place where you might get it from. Another option might be to look at where your estimates are running over. Show of hands who does estimates. Some folks do time, some folks do complexity. Okay. If an estimate runs over frequently, what's happening is there was some snag that the team hit that it didn't anticipate when it was doing the estimation in the first place. A record of what those snags were can be very helpful, because if the same snag shows up repeatedly, then that could potentially be an option for reducing your maintenance load. So that's what I would call our data-driven targets for maintenance load, but we're going to talk about a few, and that's just going to be one of them. So now we're back here, prioritizing the high leverage changes. High leverage changes are changes that produce the largest reduction in maintenance load for upfront effort. And that's what we need if our team is bailing water fast, right? If we need maintenance load to come down quickly, we need to know what these high leverage changes are. So there are a couple things. We're going to go through 5 priorities, and the very first one is going to be removing feature bloat wherever possible. Feature bloat are features that are not pulling their weight in customer value or client value relative to the amount of maintenance load that they add to our code base. We talked about how every feature adds maintenance load. Every feature adds maintenance load. So if you have features that are not benefiting your customers or your clients, then they are costing you in terms of time, in terms of effort, in terms of developer morale. And it's important to keep an eye on that. That's why I was really excited about that answer in our easy retro regarding talking with product about what the changes are going to be. Because it can be helpful to talk to product about which features are causing a lot of maintenance load. Now, it's not really product's job to figure out what features to remove. They're focused forward. They're focused on adding things. They're focused on making more stuff that works for your customers or your clients. They're not necessarily keeping track of what features might be removed. So you may have to help them here. Hey, how many support requests are we getting for our email client? How many people are using our email client? Is that something, like if our app's supposed to do one thing well, and what we're building is not literally an email client, maybe having an email client embedded in it isn't the best idea. Or maybe there's a feature that was really important back when there was a relatively small number of people using the product, and now that more people are using the product, then that feature is not relevant anymore. In fact, even if this isn't the case, I have found that a very valuable persuasive technique for talking to folks about these kinds of things is, you were totally right to add this feature back in the day because of XYZ. XYZ has now changed, and so now you would be right to allow us to remove this feature. And that way you're not accusing anybody of anything. And often it's even true. So that's what I mean by make features earn their keep. You want your thing to do what it is supposed to do very well. And it's going to reduce drag on making your thing do what it does well, to not have to maintain all this stuff that's tangential to that it does poorly or adequately or passably, but it's taking up a bunch of your time. The fewer features we have, the more time we regain to add stuff, right? And that is why, importantly, removing features does not count as maintenance load. Because it is important enough to do that it should not be, it should not affect whether you decide to do it, because it is so valuable for maintenance load in the long run. So that's removing feature bloat. Second one, addressing documented holdups that repeatedly blow up time estimates. So here's what I mean by this. Suppose that we've got a week and we don't have any feature deadlines in this week. What are we going to do with it? Suppose we even call it a refactoring week. This is where we can go into our retros, into our incident reports, into our estimations and our understanding of why those estimations were off, and find empirically backed changes that we can make that will reduce our maintenance load going forward. So this is that data-driven part that we were talking about a little bit earlier. Now, in order to be able to do this, we need to be recording the reasons the things took longer than expected. That can sometimes pose a social challenge on the team because people feel personally responsible if something took longer than expected. My recommendation here is to emphasize in a record like this that you're not trying to hold individual developers accountable. You don't even have to put developer names on it. What you're trying to do is hold your system accountable for its reliability so that developers can make accurate estimates about it. Does that make sense? So we've got two priorities so far. First of all, remove feature bloat. Bring down the number of features that you are maintaining as fast as you can, and your maintenance load will come down. Second, things that you have empirical evidence are slowing down and frustrating your team. Seems like a good set of priorities so far, right? Suppose we've done that. What's next? We can address abandoned houses at the point where a change is needed. So we talked about abandoned houses earlier, repos people don't want to touch, features that nobody's sure how they work, legacy stuff that nobody really knows intimately on the team anymore. The thing about these pieces of the code base is that they're often big enough that addressing the whole thing right away is probably not realistic. So instead, we address them at the point where a change is needed. We acknowledge that what developers are going to have to do in order to make this change is effectively rebuild context that has been lost. There's a term that I like to use for this. I call it forensic software analysis. This is going into a code base where we have lost context and attempting to recover that context. It's theoretically similar to what an archaeologist does on a dig site, or the reason it's called forensic software analysis is because it's similar to what a forensic analyst might do at a crime scene, right? Take clues from what is there to figure out what happened here. It's something that we'll need to be able to do in code bases. It can take long, it can be frustrating, and it can be slow. But it's not less of those things because we're trying to avoid it, like it's a game of the floor is lava, right? If we can explicitly acknowledge this skill, value this skill, incentivize this skill on our teams, then folks will get better at it, and it won't be quite as hard. Even if it is inherently hard, it will not be quite as hard. The other skill that we can incentivize is context transfer, which is if somebody comes back from forensic software analysis and they've learned some things about this code base, we make sure that they're either putting the code in place, putting the tests in place, putting the documentation in place, sharing, pairing with other people, potentially sharing context through review, to safeguard this context from getting lost again. So, now let's take a step back. We've got our first two priorities. Those tend to be what I would refer to as the emergency priorities. That's what's going to bring down your maintenance load enough, hopefully, that your team will be able to breathe some. Then we start addressing some of these things that we've been putting on the back burner because we've been so overwhelmed with our maintenance load. Things like addressing abandoned houses. So our next priority might be looking for places where code flexibility does not match how often that code actually changes. So we talked about an example of this, right? Where drying up your code makes that code harder to change in the event that we only want to change it in one of the places where it's used. It's not uncommon for developers to make inaccurate bets about the way that code is going to change in the future, right? And that's just part of the job. It's part of we're human, we make mistakes, we can't see the future, we didn't have the data told us one thing and then it told us something else. The product changed, the whole company changed, we did a whole reorg. All kinds of things can happen that result in the code base not having flexibility in the right places. But maybe it's something that's going to take a relatively large upfront investment of time to fix. Down here at your fourth priority is your opportunity to do that, because these are the kinds of things that require a relatively high upfront investment. As we go down this list, hopefully, at the beginning, we want the upfront investment to be low and the return on that to be high, because we're trying to get maintenance load down fast, right? So as we go down this list, usually either the return on investment is going down or it's becoming longer in time frame, or the initial investment is going up. That's what's happening with this one. The initial investment might be high, but the return on investment can also be relatively high, because particularly if what you're doing is rearranging your code base to put the flexibility in the places where you are changing your code a lot right now, then this is the kind of thing that's going to make adding features take less time, maintaining features take less time, so that your team has more bandwidth for both of those tasks. So that's this one, changing the code base to put the code flexibility where the code is changing now. Might be a high upfront investment, but has meaningful returns in the long run. And finally, equipping engineers to suggest streamlining options. So somebody mentioned this one inside of the other examples column on our Easy Retro. Essentially, being able to have a conversation with product about exactly what the feature needs to do and whether there might be a simpler way to do it compared to the given approach. The reason that this one is number 5 is that this one does tend to take a fair amount of upfront investment, not necessarily in the code itself, but in your relationship with product and the trust in that relationship. Because without that trust, it's not easy. Sometimes it's not even possible to go to product and say something that sounds like we're not going to build that, right? Generally, relationships that allow for this kind of conversation are the highest upfront investment. They're higher upfront investment than a big refactor. They're often a higher upfront investment than building something from scratch. I've seen a number of rewrites that probably should have been a conversation with product about something that already existed. But that seems like the lower upfront investment route. I'll use an example here to help drive home the point. So I work on a mobile app. I maintain this mobile app that allows volunteers, such as yourselves, to assist with scientific research. So, for example, we'll get 4 million images back from one of the rovers on the surface of Mars, and the research team that's analyzing those images for signs of water having been on the surface of Mars at some point can't go through all of the images in a realistic time frame. Say there's only 4 of them, right? But what's relatively easy for them to do is put together a little field guide that describes how to tell if this image contains signs that water might have once been on the surface of Mars. And then volunteers come along and it's essentially like Tinder, but for scientific research. So it's cool. It's called the Zooniverse. And there's one task inside of that mobile app that allows you to draw boxes around things. This is helpful for a lot of our wildcam footage. So for example, we will have a project on there with motion activated cameras set up in the Serengeti Desert or something like that. And when an animal runs into frame, it takes a picture. But we want to be able to identify all of the different species that are in these pictures, and so we ask folks to draw a rectangle around the different things that they see in the picture and then identify what they are. This rectangle drawing task has 2 modes. The first is insert mode, where you can add rectangles and change their shape. The other one is delete mode, where you can delete the rectangles if you thought you saw something but decided you didn't. So we had this code for deleting rectangles, and it was working on iOS, and it was not working on Android. And the way that this delete functionality worked was that you would get in delete mode, the way you knew you were in delete mode was that you would get a little X in the upper right-hand corner of each of your rectangles, unless the rectangle was up against the right edge of the frame, in which case it would show up on the top left. Unless it was against the right edge and the top, and then we would put it in the bottom left. Or if it touched all 4, then we would just stick it somewhere and pray. The reason this wasn't working on Android was that it had been done, I guess, on an iOS simulator, and the way that iOS figures out the locations of things is a little bit different than the way that Android figures out the locations of things. We were using absolute locations, and so the integer that we used to represent locations on iOS wasn't the same for Android. It wasn't working. So my job was to fix this. My job was to make the delete functionality work on Android. What I could have done was gone into each of those 4 conditionals and added another conditional inside of each one. If iOS, do what you were already doing. If Android, do something else. So then we would have had 8 separate conditions, 2 levels of conditionals, right? It turns out that the UI of this particular feature also was not that great. And here's why. The rectangle was green with the little X in it, and the images that we were using for testing were all black images. So a green X with transparent background shows up on an all black image. When you put it on an image of grassland, nobody can find the delete button. So we're getting all of these classifications in, and it's rectangles with nothing. Why is it nothing? Well, probably people couldn't figure out how to delete the rectangle. So there were a number of things that could have been improved about this experience. And so the designer and I sat down and figured out that what we wanted to do was make the rectangles easier to delete and hopefully make the code simpler as well. So what we ended up doing was, we already had insert mode and delete mode, right? People aren't trying to do anything other than delete in delete mode, and so we don't have to make it harder for them to find the delete button. What we can do is, rather than have only one corner delete the rectangle, in delete mode now, instead of the rectangles being green, we're going to turn the rectangles red. We're going to give them a little bit of a pink sort of inside so that it is obvious that we are in delete mode. And then if you click anywhere on the edge of the rectangle, it will delete that rectangle. because the code for identifying where the rectangle was more robust than the code for identifying where the delete button was, this got rid of the issue, and we were able to eliminate all of the conditionals and just have one straight code path, plus ship a UI that was a lot easier for people to use. But if we were in an organization where I were not able to have that conversation with the designer, then we would have been stuck at the first option. 8 conditionals for this feature that just does not work that well for our volunteers in the first place. And so that's why I say that equipping engineers to suggest streamlining options can be an extremely powerful way to get simpler code and potentially better functionality. It is often only at the very low level of implementation that you face a trade-off between the simplicity of the code and adequate functionality. But the developers have to have the ability to pop up that level, and in order to do that, you need trust with your design team or with your product team. So that's why this one is 5th. The return on investment, I think, is high, but the initial investment also very, very high. So those are the 5 priorities. Remove feature bloat, address documented holdups, address abandoned houses, make changes to where the code flexibility is located, and have engineers suggesting streamlining options with product and design. This is going to help you a lot with your maintenance load. Folks feel like experts in addressing technical debt yet? Yeah? Are we ready to test that theory out? You gonna try something? Okay. So we're gonna do an exercise now. So this is an individual exercise, and here's what I'm gonna tell you. I want you to pretend that you are now a developer. In fact, I want you to pretend that you are the lead developer, such that what you say goes, on a team responsible for making restaurant reservations. Your application makes restaurant reservations. That is what it is supposed to do well. Allow people to reserve their spot at restaurants. Now, what I'm gonna do is I'm gonna hand you 6 tickets. I'm gonna give you time to read these tickets, so don't worry. But they are all for the restaurant reservation application. What I'm gonna ask you is, first of all, which of these items would you address? Second of all, how would you address them? And third of all, how would you prioritize those projects relative to one another? I'm gonna give you time to do this, and then we're gonna go over it as a group, but this is how this is gonna work. At the bottom of this slide, you see a link. It says Ticket Priority Poll, and I wanna show you this ticket priority poll. So this is what you're gonna fill out. What you're gonna do is prioritize the issues, starting with number 1 being the highest priority, descending to 2 being the second priority. So for example, if I wanted to fill this out and I thought that this feature was the highest priority, I would do that. If I then thought that this feature was the second priority, I would fill in the bubble for number 2. Then, if I thought that this was the third highest priority, I would do this. Now, you don't have to go all the way to 6. You can leave blank the ones that you would not address. And so if I don't think any of the others need to be addressed, I can leave them blank. Okay? So this is how this works. What we're gonna do after I give you some time to work through this is we are going to go to the charts that show me what your collective prioritization are for all these issues. And then we're gonna talk about how to address them in order of collective priority. So this is what we're gonna do. This is the exercise. On the next slide, these are the 6 tickets. These are the 6 tickets that you are going to prioritize. And then we are going to go through them in collective priority order and talk about how to address them. Does that sound like a plan? Awesome. So what I'm gonna do is I'm gonna give you 10 minutes, and then at 3 o'clock, we will go over in a large group how to address these tickets. Good? Excellent. How are your answers comparing to your neighbors? We still have 3 more minutes, so you have plenty of time. See what they say. It'll be our own higher level version of the semicolon wars. The priority wars. Let's see if I can show you. 106 responses. Holy cow. We got high participation in here. These will definitely be the right, oh, I see some more. 108 responses, 109 responses. Good call, thank you. Excellent. Thank you. 112, 113, 114, 115. What do we think? Is 115 going to be the number? Leah said there's like 120 seats in here. 116. All right. Let's take a look at some of these responses, shall we? This is you. This is your responses. So the way this works is 117. The way this works is that the blue bar represents top priority. This is how many people put that as the top priority. And the red bar is the second priority. The yellow bar is the third priority. I'm not sure whether Google colors it because those are the colors of ribbons in like horse shows and stuff like that. But it is helpful for me to remember. Anybody do like a sport or a thing where you have blue ribbons, red ribbons, yellow ribbons? I did rodeo when I was a kid, and so that's the way that you do that. All right, so let's take a look at some of these priorities. And the way that I'm gonna do this is, I'm gonna be arbitrary about it, but I'll explain to you how. So here we have a couple things, right? Let me see if I zoom out, I'll be able to see all the labels on this. So I've got email, restaurant recommendation to, I can do it by hovering. Okay, so it looks like the top two priorities from a collective perspective are social auth is handle dependent. 44 people put that as top priority, and 38 people put that as the second highest priority. And time zone adjustment, 40 people put that as the top priority, and 47 people put that as a second priority. Whew, this one is close. So we're going to talk about social auth being handle dependent first, since it has the highest number of first priorities out of these two. What I'm going to do is ask, why was this social auth handle dependent one your top priority, if it was your top priority? Can I have a show of hands? Would anyone be willing to speak to that? Why was this one a high priority? All right, we've got one down in the front. Hang on, we'll get you a mic.
Seem to be the one generating the most actual problems. Like 12 emails to support a month doesn't sound like a lot, but I don't know how many users we have. But all the others seem to be less impactful.
Right, yep. We have a measured impact of this one. People are actually complaining about this working. It's something that has to work in order for our thing to be able to function. Right, yeah. Okay, so this one is, as a reminder for y'all, we probably get a dozen emails a month about this. Now, to logistics, the authentication code is in the API repo, which is an old Django app. No one currently employed here knows much about it. The documentation consists of how to get it running on a machine, but there's no endpoint don't documentation, no Swagger, no troubleshooting guide. There are unit tests, but no integration or functional tests. How might we address this? Folks have thoughts on how we might address this? Show of hands. All right, we got in the Stripe here or anywhere, but.
So how to address this? It might depend a bit, of course, but I would even think, given the requirements, it doesn't seem like a very complex thing to solve. So maybe it's even worthwhile to get rid of this old Django application and write it in a way that's more consistent with the way the good practices that we just discussed, or the best practices that we just discussed. And so we actually kill two birds with one stone. We solve this user problem, and we get rid of this legacy technology. And so after finishing this, or the whole team now knows how this works, or ideally, of course.
We could potentially do that. Completely rewrite the thing. I call that the nuclear strategy. It's an option. Sometimes it makes sense. Anyone been a part of a rewrite? Show of hands. Been a part of a rewrite? Yeah. They're expensive. Very, very high upfront investment. Might make sense in some cases. Does not necessarily make sense in all cases where we've got old code, right? We might not necessarily be able to rewrite it. Thoughts on what else we might do? I see one over here, maybe.
Hi.
Hi.
So this sounds like an abandoned house that you described. So nuclear rewrite could be an option, but probably you'd want to focus on forensic analysis to understand how the thing currently works.
Yeah.
Learn about how it works and transfer that to the team so it's no longer so scary.
Right, yeah. Definitely an abandoned house here. Nobody knows how this code works. Tests, not particularly instructive. Unit tests, super instructive when you've got complex logic happening within the bounds of one class. But if you're talking about an entire service, integration test might be more instructive on what's supposed to be happening. This code base doesn't have that. So some forensic software analysis might be in order, and some context transfer. Maybe the first step is writing an integration test for that service and using that as the driver to figure out how it's working at some point. And then, or fixing this as an opportunity to figure out what's happening, such that if we're gonna keep this, if we don't end up rewriting this, further maintenance will be a little less painful. All good options, excellent. All right, so let's talk about another one. Second priority here, this time we're gonna go to the other one. Time zone adjustment. Would anyone like to speak to why this one was a high priority? Thoughts on this?
Hello, my name is Oscar.
Hi, Oscar.
I chose that one as a highest priority because, say if it does work, you're going to have two parties that are going to be unhappy with the situation. So as opposed to the authorization, if it doesn't work, it doesn't go through. So you don't have two disgruntled parties, you only have one. So that one, I feel like it's more relevant.
I see. So there's multiple disgruntled parties here. You've got the restaurant's not going to be happy because they didn't get a reservation, which is the whole reason they pay you. And people trying to make a reservation aren't going to want to use you in the future. Seems like a pretty high priority feature. What might we do about this? Thoughts? How do we want to address this time zone adjustment feature? As a reminder, yeah, go ahead. As a reminder, this is 92% of our members live in the same time zone as our database hosting, so the adjustment code doesn't run for those 92% of people, but for some reason it consistently mishandles time zones that are behind the database time zone. So if the database is centered in Chicago, then it's not working for folks in California. It shows all the reservation slots as earlier than the restaurant intended in those cases. It adjusts to time zones ahead of the database time properly. This code works as long as the database time zone is behind the time zone of the end client.
So maybe just drop the feature?
Drop the feature. That is an option. We could not support time zones such that all of the times are shown in UTC, Meridian time. We could. People would probably have to translate it back themselves. It's an option. We could say from now on, we will only work with restaurants in the database time zone. So that's an option. We could do that. But it is, yeah, but I mean.
Well, I meant more like 92% of people live in the same time zone, so just keep it on that one time zone.
Yeah, so 92% of people live in the same time zone, so we could keep business on that one time zone. That is an option. That's a thing that we could limit it to. And it would depend, on the future of the business. Does the business want to expand into other time zones? Is it cool staying in the local time zone? But 92% is a lot. It's easy, and product very often will do this too. There will be a focus on the majority use case. And the majority use case can be useful for getting something out the door. Usually for your MVP, the majority use case is all right. As we start to try to build a robust application that's going to support change and growth and team changing and all those kinds of things, it becomes very important for us to understand the primacy of the people who are using our application at the margins. And a lot of visionary application development work comes from considering folks that the market has not considered thus far. My favorite example of this is the 2007 iPhone speech, because everybody talks about it and miscontextualizes where it came from. But there was this vision. Steve Jobs was this visionary, and he came up with this amazing device, and it completely changed phones for the remainder of known history so far. Well, a lot of the things that were visionary about the iPhone got put into the iPhone after they were acquired by Apple from companies often that were founded by and for folks with disabilities. This is fundamentally an accessibility device. The multi-touch capacitive screen completely changed the way that phones work because you're no longer beholden to those buttons, right? And that functionality came from a company called Fingerworks that was focused on allowing human-computer interaction for folks who were losing or didn't have fine motor skills. Apple acquired the company in 2005 and put the technology into the phone. A lot of the most visionary software ideas come from centering folks at the margins. And the reason that I say that is because I want to caution folks about focusing on the majority when you've only got, when it seems like a relatively small percentage of folks who are using our application under certain conditions. When we're trying to get an MVP out the door, maybe we can't focus there. But as the product grows, it becomes important to explicitly put our focus there. And many of the products that begin with the marginal case in mind end up being the blockbuster visionary products that we talk about for as long as we do. Now, one clever solution that I've heard to the time zone adjustment problem on a couple of occasions is figure out what the last time zone on Earth is and change the database to the last time zone on Earth. That way only the code that works ever runs, which maybe is removing the feature. It's removing the code path that causes the problem. So there's that too. And I love it. In my experience, from a practitioner standpoint, one does not simply change the database time zone. But if that were an option, then that would eliminate the code path that's causing the problem, right? And then we can just delete all that code, which would be kind of nice. I love deleting code that doesn't work, don't you? So that's an option. All right, let's talk about our third, priorité. Looks like it's this one. There are a number of blues here, number of reds here, number of yellows. Email restaurant recommendation to a friend. Thoughts on why this one's high priority?
I put this one as top, although I'm sort of reconsidering whether it's actually time zones because that's such a bad bug as to make the service useless. But this also makes the service useless, right? Like all other functionality that we've talked about here is broken when the site is down.
That is true. All of the other functionality on the site is broken when the site is down.
And it's a useless feature we can remove easily.
And it's a useless feature. As a reminder, our servers crashed 3 times last year from accounts signing up and spamming people restaurant recommendations. Besides those incidents, the only account that sends restaurant recommendations is the CEO's, so it's clear whose idea this was. Fun fact, unrelated, but I want to share it because I think it's funny. When we were doing the dry run for this workshop, Leah pointed out, I used to say our servers fell over 3 times, which in the context of restaurants is ambiguous. So now it is our servers crashed. How would folks like to address this? Thoughts? How would folks like to address this email or send restaurant recommendations to a friend? Feature. Any thoughts? I see one in the, can we call it the hallway track if it's not the hallway track, but it's in the hallway of the workshop track?
I think you have a couple options. One, you can completely delete the feature. 2, you could limit it only to the CEO to keep him happy. Get some political goodwill there. Might come in handy later.
That's true. That's true. So one option, delete the feature. Other option, don't delete the feature, but put a feature flag on it and turn it off for everyone except the CEO's handle. Could work. You know what? In certain circumstances, that's what you got to do. One time, I was telling somebody a story about this in the hallway earlier. There was long story short, a decision that we had to make that sounded like it didn't make sense with an application, and it resulted in a designer needing to make a new icon. Ask me in the hallway if you're interested. And when I told my designer this, same designer as the rectangle story, by the way, her response to me in email format was one line, and she was like, please tell me this is a constraint and not a goal. And it was indeed a constraint, but that's what I would think of if I saw code like this that was like, if username equals CEO123, display button, restaurant recommendation to friend. That'd be my first question for that client. Please tell me this is a constraint. All right, so that's that one. Let's see. What else we got? What else we got here?
Hey, Chelsea, we've got one more.
Oh, okay.
So I think the point of that story is obviously that we should delete the send recommendation feature, but I think it speaks to an architectural problem. Like, people sending too many emails should not bring the entire service down. Like, that should be a job queue that's independent of your homepage. So you can't just delete the feature and move on. You gotta have an architecture review.
Potentially. There may be value in figuring out how this happened, because it may speak to a larger architectural problem with the application. So that is a potential, something that we might potentially want to look at. Now, if the situation is you're getting DDoS specifically having to do with people being able to use an email client in your application, and you remove the fact that people are able to use an email client in your application, then presumably at that point you've removed the vector for attack, right? But if the send restaurant recommendation to a friend feature is on top of functionality that you also have in other portions of the application, then it's an indication of a vulnerability across the application, right? Something that we might want to keep in mind. So that's a good point. Thank you for bringing that up. All right, let's talk about our next priority, which looks like it's going to be between these two. I see 3 votes for object-oriented restaurant code being the top priority, and 3 over here. Okay, let's try 6 for second. 6 for second. Everybody agrees. 20 for third, and 12 for third. So let's say this object-oriented restaurant code thing is the 3rd priority. For folks who saw this as a high priority, would someone like to talk about why they saw this as a high priority? As a reminder, the code for restaurant behavior is written in an object-oriented fashion with each restaurant type in its own class. Last year, we added 1 new type of restaurant. To do it, we subclassed restaurant and no-op the reservation methods. We also added 6 new functionalities to restaurants. So, thoughts on the priority? Why should we address this one? I know 3 folks had this at the top. 6 folks had this as second. Thoughts?
I figured this was, I'm not sure on what position I put it anymore, but I think I put it on the top 3 at least. So for me, the consideration was that this sounds like something that works now, but that will actually cause us a lot of pain in the future, because it seems like there's a lot of features being added here. That might also be true for the upcoming period, that there might be even more features, and this is some sort of a disaster waiting to happen. So might something that we want to address right now when it's still manageable, or when it seems manageable, before it becomes out of control, and we are back in the social authors handle dependent, where we have an abandoned house and no one knows how it works anymore. That was my consideration.
Okay, so it works now, but in the future, this could potentially cause a lot of problems, right? We've got code here that is flexible in the direction of types. It's easy to add new types of restaurants, but we're not adding types of restaurants very often. We're adding functionalities all the time. And because we've put all of our code flexibility in adding types of restaurants, we can't add functionalities as easily. So And we're even ending up with there's code smells in this. We're subclassing things with no ops. That's usually an indication that our inheritance structure isn't actually representing the thing that we would like it to be representing. Thoughts on how to address this? Anybody? Okay, we've got one here in the middle.
Backing up a step, it sounds like this is one where working with the product group to find out what the plans in the future are. Because even adding 6 functionality in a year, maybe that's not enough to really make it worth the effort. So I really want to know, like, what's the roadmap for the next year?
Yeah, that might be helpful to know. How are these, is this rate of change going to continue? Is this rate of change going to, is this going to flatten in the past year? This has been a particularly difficult one for teams over the past 2 years because so many things changed. If we're talking about a restaurant reservation app, the way that people interact with restaurants has changed so much in the past 2 years that there's really more information needed here to figure out what might necessarily be the case. Now, if we've got a situation where our malleability isn't lining up with the changes we're making and those change patterns are going to continue, we might be in a situation where doing a refactor towards more functional code, towards something where it's easier to add restaurant functionalities rather than restaurant types might be in order. It would be a high upfront investment. But if those changes were going to continue into the far future, it might be worth it, right? All right, let's chat about our next one. We've got 2 more to go. And I'm going to say this one got a lot of votes for being last priority. So we're going to do case-sensitive API endpoints. Thoughts on the importance of this one? Got a couple votes for first here. As a reminder, this is case-sensitive API endpoints. To fetch reservations from our API, the endpoint is a GET request to an endpoint ending in /R reservations. Little r reservations doesn't work. We have 3 clients, basically our mobile apps and our web front end. All the developers roll their eyes when they have to explain this to other developers.
Hey there. Oh, hey, can you guys hear me? So I thought this fell kind of under the second priority that we mentioned. Issues that would increase kind of like time, I guess limits within a retrospective. So like how long? It sounds like you have kind of like junior developers getting confused already based on why the API doesn't work when it should be like case insensitive. And it also seems like a straightforward fix. Just make the API case insensitive. So the existing functionality still works. And then you remove this obstacle for developing in a speedy manner.
Yep. So we've already got people potentially getting a little bit confused about this one. And these endpoints, developers roll their eyes when they have to explain it. Conveniently, we're not in a situation where we have a lot of clients using this. So even if we're not in a situation where it's breaking anything yet, we don't have that many clients to change. And so theoretically, it's a relatively low upfront investment to change, right? And we want our early changes to be as low investment as possible. So one of the arguments that I've heard for this one, initially when I created these slides, I thought of this one as relatively low priority. And the reason that I thought that way was that this is not something that external clients are getting confused about. It's only internal clients. And the other reason I thought it was low priority was that developers were rolling their eyes when they explained it to other people, but that meant the developers knew the situation and they were explaining it to other people. So I wasn't too concerned about it from a priority standpoint. But over the course of teaching this workshop, a couple of attendees have pointed something out to me that's made me think that this one could potentially go a little higher on the list, which is that I wasn't necessarily taking into account developer morale, and this is one that theoretically should be a pretty quick change. Not only would it be a pretty quick change, it's a change that might potentially make sense for somebody who's new to the team. And that would be a big confidence boost to be able to make this change that's going to make things less frustrating for all of the other developers on the team without necessarily requiring a whole lot of changes to the code. So taking into account sort of developer morale, I think this could make sense higher up the list depending on your team. Because if your team has felt mired in debt for as long as you've been there, maybe even a little win like this one is going to help them gather the resources that they need from an interpersonal perspective to be able to tackle some of the bigger changes. All right, so we have one last one. The absolute winner on lowest priority, which is functional navigation. Thoughts on the priority level for this one? All right, we've got one here. As a reminder, our new senior software engineer came from writing Clojure, and he would like to experiment with a new functional approach to navigating between screens on our mobile apps. All right, so I stacked the deck a little bit on this one with that story earlier. Whoops. Yes.
So for me, I put this as the highest priority.
Okay.
But I think the argument mostly kind of comes in terms of what type of developer you are, in terms of whether or not you're customer obsessed, in terms of where is our majority customers using these kind of market shares, or if you're the other side where you kind of hate on your customers, so to say. I don't know how to call that. But regardless of the fact, the functional aspects is that nowadays we're trying to componentize our UI and various things like that. So ensuring that you're not losing out on any potential market share, say, for example, Facebook switching to mobile when mobile became the biggest market share. They had to hire or redesign their entire system to be able to cater to that. So I place this to the highest perspective because this actually affects our customers, and being able to kind of redesign and build new components on top of the UI that you already have will give value to the customers in the future.
All right, I can appreciate that. Thoughts on how we might address this?
I think that this is the lowest priority, not because I disagree with your argument, but because to me, this is a sign that you're adding more tech debt. You're adding harder stuff to maintain. People don't know it. There isn't a problem. There are actual problems here that people are encountering, or, like the team itself. And this isn't a problem yet, and we're not sure it's going to be a problem, so it doesn't seem like it's worth addressing. And I also think bringing the new senior engineer more in line with what the team is already doing probably makes more sense than immediately being like, hey, go do your own thing. Just from a come join our way perspective.
Yeah, I appreciate what you're talking about with regard to what might be valuable for customer retention in the future and those kinds of things. Those are absolutely things that I would want to consider in adding a feature like this, so I appreciate that you're bringing them up. Given this description, it seems like those customer acquisition and customer retention things aren't necessarily factoring into this developer's calculation of why they want to do this. What we've got here is, well, we'll see. Somebody over there?
Well, I kind of agree that it's definitely still the lowest on my priority list. I would be willing to, it's still important for with new developers to also be trying new style, because it may turn out that this is actually an ideal style rolling forward. That being said, I'd probably do a timed, make sure we can be willing to pull it out if we find out that it's actually burning us, being able to drop that feature really quickly. But at the same time, I do believe in the controlled experiment of letting that part of the code base grow. It's if we can contain the experiment, it seems like at least worth trying. If other developers have appetite. If it's only this guy, yeah, fuck it. But.
So there are definitely opportunities. There's opportunities for time boxes, for hack weeks, right? Again, a lot of products that companies ended up basing a lot of their strategy on came out of hack weeks because it was tough to socialize something, right? And potentially this might fall into one of those. That's a possibility. It's something, you bring up a good point with regard to whether it's just this person or other people. Often what happens with pet refactors is it was either not socialized with the rest of the team, or it was unsuccessful in convincing the rest of the team, both of which are signs that maybe we don't need to be doing this right now. The first step is figure out how much of the team could get behind a change like this. So socializing those changes is really important. Another thing that I've had attendees bring up in this workshop before about this one is, if this developer is really interested in switching us to a more functional approach somewhere, then we could assign this developer to the purple ticket, in which there's potentially a customer-focused product-focused reason for us to be switching to a functional approach from an object-oriented approach. And so that might be something that makes everybody happy. Of course, that, just like with any technical solution, is something that you might have to socialize. But that could potentially be an option here that I've appreciated folks bringing up in the past. You made it. You made it through the hard exercise. Congratulate. Give yourselves a hand for that. I'm very impressed. I'm proud of y'all. This was a lot. We went over a lot. So I'm happy to take questions, although I think I'm about to be out of time. But one thing I want to point out is that I have a feedback form for you right here on the last slide. This will link you to a Google form. I am very, very serious about improving on my workshops. And so I would really appreciate it if you could answer those questions. It's going to help me make this workshop better. It's going to help me expand it for the future. There's also an option there to put in your email address if you would like to hear about future expansions of this workshop. So with that, I really appreciate your time, but I'm happy to let you go for the day and stick around for questions.